chemical properties of carbonyl compound. We are going to look at the reactions in carbonyl compound. First one is nucleophilic addition of C double bond O, the carbonyl group. Second is reduction reactions, and the third one is condensation with NH3 derivatives. Let's look at the nucleophilic addition of carbonyl first. The nucleophilic addition of carbonyl can be divided into 5: addition of KCN in H plus or NaCN in H plus. It's acidic. KCN or NaCN acidic. The second one is addition of acidified water in the presence of acid, and addition of alcohol, addition of sodium bisulphate, this is the formula for sodium bisulphite, addition of Grignard reagent, this must in situ preparation, must be prepared during the reaction. The Grignard reagent must be prepared if you want to make the reaction. Addition of KCN in the presence of H plus or NaCN in the presence of pH plus. The reactant can be aldehyde or ketone and HCN. Actually, we want to react the aldehyde or ketone with HCN, but we don't directly use HCN. Instead, we use NaCN in HCl or KCN in HCl. The product will be cyanohydrin. Cyanohydrin means the carbon that has OH has CN. That is cyanohydrin. Okay, the product will be cyanohydrin. We don't directly use HCN. Instead, we use NaCN, HCl, and KCN, HCl. This is because HCN is very volatile, extremely poisonous, and a very weak acid to produce enough Cn minus ions for the reaction. Means HCN, the Cn minus ions, the H plus from Cn minus ion is very weak acid. So it is not suitable to be used directly HCN. Plus HCN is very volatile. If you want to react aldehyde directly with HCN, the HCN is gone because it's very volatile. Therefore, you have to use NaCN or KCN in HCl or H2SO for any acid because we need the H plus. But the acid that you use must be strong acid because we don't want very weak acid because it won't produce enough Cn minus ion for this reaction. Because we know weak acid is partially dissociated, we need strong acid because we need more Cn minus ion. This is aldehyde reacts with NaCN or KCN in the presence of HCl or other acids such as H2SO4, and the product will be cyanohydrin. This C double bond O, this carbon will be carbon attached to OH. The double bond O here will be converted to OH, and then this C will form one more new carbon, Cn. Okay, this addition of KCN or NaCN is very useful if you want to add one more carbon. You can add one more carbon. If you look at here, initially we have 2 carbons only, but at the product we have 3 carbons. If you want to add one more carbon, this reaction is suitable for addition of new carbon. Next, addition of water in H plus. The reactants can be aldehyde or ketone and water. We need to react aldehyde or ketone with water, so that's why the name is addition of water. In the presence of H plus, the product will be hydrate. Okay, hydrate means the same carbon, C double bond O, this carbon has OH group, 2 OH groups at the product. H2O reacts with aldehyde or ketone in the presence of acidic H plus. So this carbon double bond O will attach to 2 OH groups. Or we can call it germ-diol, germinal, it's side by side, germinal. And then this in basic medium, okay, in basic medium, can also do the addition of water. H2O in H plus or H2O in OH minus. The product will be the same. You can produce hydrate or germ diol. Remember, the carbon that has 2 OH group is the carbon double bond O initially. So from here we can conclude that hydration can be carried out in acidic or basic medium. Next is addition of alcohol. Reacts the aldehyde or ketone with alcohol in the presence of acid H+. Okay, it will produce this C double bond O will become OH, carbon attached to OH, and it will form one more new bond with oxygen, not with R. One new bond with oxygen. Okay, this oxygen from alcohol. Oxygen followed by whatever your R is. Further reaction with alcohol will produce both OR, OR. It depends what R that you use in the reactant. And the side product is H2O. Ketone, same as well, reacts with alcohol in the presence of acid H+. This C will form OH initially, and then one more new bond, C bonded to OR, not to R. Make sure it is bonded to O. Further reaction with alcohol in the presence of H+, and it will produce both OR. This OH will be converted to OR from the alcohol. And the side product is water. The product, if you look at these two products, they are the same, but the name are different. This carbon has OR, OR, this carbon has OR and OR as well. But if you look at the name are different. This name is acetal because initially it comes from aldehyde. If it comes from aldehyde initially, the name will be acetal. For this one, initially it comes from ketone. The name of the product will be ketal. Hemiacetal before further reaction. This hemiketal before the further reaction. For example, here we have aldehyde. Aldehyde reacts with alcohol. Here we have methanol, the presence of H+. This C double bond O will become OH, COH, and then one more new carbon bonded to OR. Our R here is CH3, so it will be bonded. The carbon will be bonded to O, CH3. This is hemiacetal. Hemiacetal means before further reaction, means you still have the OH group. After that, further reaction with the methanol and the acidic. So it will form acetal. Both OR, OR. Our R is CH3. Acetal because the initial reactant is aldehyde. For this one, initial reactant is ketone. Ketone reacts with alcohol in the presence of H+. The name, this C double bond O, it will become COH. Still have OH group. The name is hemiketal. And further reaction, the OH group will be replaced by this CH3O. So both OR. This is ketal. Because the initial reactant is ketone, so the product will be ketal. If the initial reactant is aldehyde, the product name will be acetal. Addition of sodium bisulphite. Reactants can be aldehyde or ketone and sodium bisulphite. NaHSO3. This is sodium bisulphite. So for example, here we have aldehyde reacts with sodium bisulphite. The product will be the C double bond O will become COH. Okay, this bond must be bonded to O, not H, not in the middle. C bonded with OH. And then one more new bond will form C single bond SO3 minus Na plus. Okay, this is ionic bond. SO3 minus Na plus. This is ethanol sodium bisulphite. Whatever you have at the front, if the reactant is ethanol, so the name will be ethanol sodium bisulphite. Next addition of Grignard reagent, it must be prepared in situ. It means you have to prepare during the reaction mixture. If you want to do the reaction, then you can prepare it during the reaction. Methanol produces primary alcohol. Other aldehyde produces secondary alcohol, and ketone produces tertiary alcohol. That's when carbonyl compound reacts with Grignard reagent. Here, the Grignard reagent prepared in situ before we want to do the reaction with Grignard reagent. So make the Grignard reagent first. This is our Grignard reagent. Reacts with methanol. The product will be primary alcohol. This is primary alcohol. And then next, we have aldehyde other than methanol. Aldehyde other than methanol, it will produce secondary alcohol. You've learned this in the preparation of alcohol, chapter hydroxy compound. And finally, if you react the Grignard reagent with ketone, the product will be tertiary alcohol.